Hello, we're back again. I'm just going to start this program here. And what this is an example of a soft color morphing. And that's what I want to do, as opposed to just being one of like 12 kind of on-off RGB values or whatever. And what this is it's using the Arduino's PWM. Well, actually, what it is just using the digital right up and down, and it's done totally in software. It doesn't use the Arduino's PWM. I wanted to see what I could do without using the PWM, and it's on the digital output, so there's no voltage control at all. It's just 0, 1. I'm altering the duty cycle, and what this program really does, it starts at RGB 000, and it looks for a random number, which on the RGB cube is about a quarter of the size of the RGB cube. It's designed to go between certain, like a quarter to like a little over a quarter of the size, and then it guesses a new point. The second point becomes the first point. It gets a new point. It moves on. And anyway, so what this could be used for is this same driving signal here could be used as a bias signal for some external equipment under an external power supply for a bank of LEDs that I could put together. And I think I could probably handle putting together a power supply, biases, biotransistor or something to power a bunch of LEDs. It's not an inconceivable project. Then I'd have variable lighting, computer-controlled lighting for my apartment, which is kind of interesting. That kind of interests me. I'm a little bit worried about backfeeding power into the USB port and blowing away my computer. I guess I could try it out, using a laptop, cheap netbook or something, just to make sure that it's not going to do that. But yes. Again, the camera it always gets kind of like a white spot there, so I put something behind it to try to get a feeling for diffuse. I mean, with my eye, it kind of looks normal, but this is kind of a crude RGB LED because it has the 3 emitters beside each other, so you can mostly see, like in the glass case, in the diffusion of the three things, but they don't necessarily mix great when you look straight at it. You can kind of see the 3 LEDs. But I would say that my basic idea was, I've achieved my goal of creating a color morph with this LED and using the on-off duty cycle with an Arduino. That was really the objective. Okay, so I just make a color cube, which is a way for me to move between colors, and I just say, as for example, one direction is red here. Let's say this one is G here, and this would be the B direction, and the values are 0 to 255. Now let's see if what's a good way to draw this? No matter what I do, it's gonna always make a thing, but let's say I go from here to here, right across the cube, right? So I've gone from one corner of the cube to the other corner of the cube. That is 442. That's the length in terms of the other ones being 255. And the formula, the same thing for Pythagoras formula, but you just use the R direction squared plus the G direction squared plus the B direction squared, right? So let's go to another color. Let's say my initial color, we'll call it 0, 0, 0, right? 0, 0, 0, that's the initial position. Whenever you draw something in a perspective or isometric like that, you don't really know where that is. And you can say that's, maybe that's, I don't know, maybe it's this point here and this point here on the, where they meet. But you have a line vector. Okay, we're still going to use the same color. So you have this line vector here, and the idea was that we're going to find a new point. So let's say I find another point over here, and it's going to go to this point, right? So that's what I'm doing, is I'm going between points in the RGB cube, and what I want to do is I want to have like a uniform amount of time for moving to that new thing. What I decided to do was chop this, I'm just exaggerating, they're very small steps, into a number of steps, right? So however, no matter where it is, the steps are always the same size, right? So I'm trying to figure out how am I going to figure out how to get these values. It's actually not that hard, because all you have to do is figure out how long this is here, and that is a number, that's a scalar number, and you divide it by whatever the distance is here, right? So then what happens is this particular thing, it's changing, there's a length, right? It's going so far this way, so it's so far this way, it's going so far this way, for example. So what I have to do is you have to figure out how far it's gone and divide it by the number of steps, which is this number divided by the length of the steps. So that's what my program does, and it manages to then get all these points here, all these points that are going between there, and actually yes. Anyway, so that's what it does, and it gives me a list of these points that are following along these lines, and I'll just go over how the actual program works, or how the program was written. So yeah, I just threw this together, and I used parts of my other program, which was the controlled NEC remote controls. It has a lot of the same stuff. This here is setting up the USB connection, and this part here, yeah, that's still setting up the USB connection. And here is a function for returning a random integer between a lower and upper limit. Okay, that came from the other program. This one here is describing the variables that'll be used in the main program. I didn't go into any subroutines. I just did everything the main section. There's a never-ending loop, which is basically a while loop that has a condition that's not met. So what happens here? First point is defined as what's going on here? Okay, actually the 2 points are defined as 0 in the declaration, and then the point. Okay, so it looks like I didn't do it quite the way I thought I was going to do it for some reason. I didn't start with black. I immediately started to just describe the first point as a random number. I'm just looking, I'm going like, did I do that? But yeah, apparently I did that. That's what it says here, and that's not bad. It just means that it doesn't start black; it just jumps into being something else. But what it does is the first thing it does is it describes one point as a random number, and then describes the second point as a random number, and it says it has to be like a certain distance from the original point as a vector between the 2 points. It has a length that is 90 to 100th, apparently. So this is the way I wrote this program, and maybe you get better results if there were some other values there, like maybe 50 to 200 or something. It might be more interesting to look at. It's hard to say, but you could mess around with this. So then what it does is it figures out the delta in the direction of the red, green, and blue. Figures out how many steps of a certain fixed length exist in the vector of the size, that is the size between the 2 points. It figures out per step how much the number has to change to get that. Then it goes into a loop where it's going from all the steps, and what it does is what's going on here? It says how many of the steps multiply, yes, step size by the counter. So as the counter goes up, get times this times that. The offset, it keeps increasing from the original point until you get, I think you get the other thing, but it's trunk, so it could be a little less, but it's basically the same as the end. And then what happens here is, okay, so we get an RGB coordinate, but we know that this number from 0 to 1000 is that represents white is not the same thing. So what I have to do is I have to multiply it by 3 scalar values, just basically scale it to get the one that is to the lead, the red, the white one, which is more red than anything else. Okay, so it's less green, a little bit blue, but mostly way higher in the red. So then what happens is I'm going to then write the code to the Arduino through the USB. But what I've done in this case, and I just looked this stuff up, it's kind of thrown together. But instead of using fprintf, because it doesn't seem to work with a file handle, it seems to work with a file stream, I use this thing snprintf, which performs a printf formatted print, very, very useful. So I can just describe the way to do it, and the computer will figure it out for me. It writes it to a buffer, which is basically a character array of 256 bytes that I've made here. And then what it does is it performs a write function from the buffer and using the write function, not the fprintf function, to the USB channel, right? And then here what it is there's a small wait which is controlling the rate at which it's changing. It's a small delay in the computer that's controlling the rate at which the colors are changing. It's moving along the point. Okay, so that's it.